All right, here we go. So, from last night's homework or today's homework, um, you had two different objects. Okay, and you need a set of equations, sorry, set of variables and an equation for each object. Okay, if you have two parts or multiple parts of a journey, you need a list of variables and an equation for each part. Okay, so just big picture, if you ever have anything that's like different types of motion, whether it's different objects or different stages in a process, you need variables and an equation for each part. Big picture. That you're going to carry that the rest of the year. Good with that? Okay. So here we have a workout. You have different stages. You got the jogging phase, and then you have the walking phase. And I want to know the average velocity for the entire process. Okay. So you have the jog, you've got the walk. And for this scenario, you also need the total. Okay. So I want you to list your variables. So displacement for the jog, time for the jog, and velocity for the jog. Displacement for the walk, time for the walk, and velocity for the walk. Go ahead and fill that out. Okay, hopefully this wasn't too bad. This is 4 meters a second. You need to convert your time to seconds. Okay, because we're given it in meters per second. We're given in meters per minute. You wouldn't have to convert it, but typically the default mode is convert time to seconds. So if it was 2 minutes, it would be 120 seconds. If it was 20 minutes, then it's 1,200 seconds. And likewise here, you have 2 meters per second and 1,200 seconds. Doing okay? Now, to find our average velocity for the entire workout, you take the total displacement divided by the total time duration. Doing okay with that idea? So in order to find the total displacement, you need to find the displacement of the jogger plus the displacement of the walking over the time jogging plus the time walking. Okay. Do we have a value for this? Not yet. What about this?
Teachers, at this time, please send freshmen with the last names that begin with O through Z to the auditorium.
So what do you need to find first? Both of those. Okay. So I am a really big fan of writing the equation that you're going to use first before sticking in numbers. I'll make you do that on the test. I'm not going to make you do that on homework. I'm not going to police that. But on the test, I'm definitely going to want you to write the original equation, even if it's the only one you've got. Find that to be 4,800 meters for jogging. Find that to be 2,400 meters. So when you do the math, it turns out to be 3 meters per second. Wow, that was a lot of work for something I already kind of assumed it was the right answer, right? But do you see the process? Does that make sense? Yeah, Marla. We converted this to seconds. Okay. Other questions? Okay, let's change the scenario. Let's say you go on a 100-mile road trip. Okay. For the first 50 miles, you're going 60 miles an hour. For the last 50, you're going 80 miles an hour. What is your average speed? And assuming no pit stops. I should have flipped this. So like going, I don't know, somewhere maybe Bloomington. So going from here to Indy, you're on 65, going 80 miles an hour. And then from Indy to Bloomington, it's all those stoplights, even with the okay, you're going slower. Okay. What is your average speed? You don't necessarily have to solve for it, but just kind of think about it. You can solve if you want, but have a conversation. Okay. Two popular answers. How many people say A? How many people say B? Anybody say C? Good. All right. Now, what is the difference between this question and that question? Okay.
It's miles instead of minutes.
What is?
Like for how long you basically doing stuff, you have to use the miles to figure out how long you do it.
Okay. You're on the right, I think you're on the right track. Leo. Okay. I mean, yes, we are. So what? Let me coach Emma.
They're measuring the trip in the first one by how long it is, but they're measuring the second one, or the second one about how long it takes. The first one, the second one, like how long in miles.
Okay. This one, you had equal time durations. This one, you have equal distances or displacements. Okay. Those who said A, why did you say A? Okay.
Well, you're driving for longer on the first 50 miles, and you're driving like less on the
Longer what?
longer
Time.
time.
That's what I was. Okay. Which 50 miles takes a longer amount of time? When you're going 60 miles an hour. Does that make sense? You're driving 60 miles an hour for more time than you are driving 80 miles an hour. So that's going to take your average down. You can figure that out with this math. Okay. That's why I went through all the math for something. You're like, well, that was stupid. I knew that. Okay. Not always. Okay. If you do this math, it turns out to be like 68 miles an hour or something like that. 68 point something. I don't know. 69, something like that. Go to that. Something less than 70. How are we doing with that? So this strategy is what you're going to be doing for 7 and 8. That's your homework tonight. Okay? Good there? Marley.
So we can so we can plug in those numbers in this equation right here.
Yep, you got all your variables for the going fast. You got all your variables for going slow. Okay. And then you have your total. Mm-hmm. All right. So, lesson 2. All right. I need 6 volunteers. 1, 2. Oh, come on, people. Help me out. 3. Halfway there. 4, 5, 6. All right. Come on forward.
Whoa.
Dance party. Man, that's rough. Let me turn that off. Oh, it's turned off by itself. Such a sad day. Okay, that's going to be problematic. All right, we'll just do this the old-fashioned style. All right, so what I have here, piano students, the metronome set for 1 click every second. And I have here a watermelon. Just kidding. It is a bowling ball. Okay. What I'm going to do is I'm going to roll the bowling ball. And every time this clicks, I want one of you to stand right where the bowling ball is at that. Okay. This will be a trial run. Right there, 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 there. That's how we do it. Okay. So here we go. Ready? There, 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 there. We'll just assume we're good. Cooper, we're gonna put you. We'll assume the bowling ball made it there. All right. Hold out your hand. Hold out your hand. Okay. What you're looking for. Flip it over to the black numbers. You're looking for the red number to your right. You're fine. You're 0. That's your number of meters. And then, yeah, you want there. It's your 1.3. You are 2.8. You are 3.9. You're 5.2. 6.4. Okay. Remember your number. Remember your order. Okay, very good. Just drop the tape measure and have a seat. All right. So, such a sad moment. I don't get that. Go. So, 1, 2, 3, 4, 5, 6. Okay. We're going to position in meters on the y-axis, time in seconds on the x-axis. Okay. You do that. So, Finley, what was the first one? 0. Second, 1.3. Next one, 2.8. Okay, next one. Next one. After 3.9, 5.2. Sounds good. Okay. Was that the last? 6.4. Well said. Okay. So we have our data points. Draw best fit line. Use a straight edge. Ish. We'll go with it. Okay, so let's pretend I did that with a straight edge. Okay, best fit line. Okay, now Slope. Math folks, what is it? How do you find it? Slope is equal to rise or run, which is, another way to say that is change in y over change in x, y2 minus y1 over x2 minus x1, yeah? Okay, might have been a while, but hopefully that's in your brain rattling around somewhere. Okay, now we're going to find the slope of this best fit line. I'm going to pick points that the best fit line crosses the grid perfectly. Okay, the best fit line takes the average of the data. You know how, like, in experiments, there's some error, there's experimental error. Okay, the best fit line tries to average that out. That's why you draw the best fit line. Okay, so I'm gonna look at points that are like right on the grid. So that point's right on the grid, and this point looks pretty close. Do something. Come on, baby. Yeah, that looks pretty good. We'll do that. Okay, so those 2 points. So this is point 1, this is point 2. Does everybody understand why I'm picking those points and not the actual? We're drawing the best fit line. There's some error in our experiment. This best fit line averages that out. That's why we draw the best fit line. Okay, I'm picking points where it crosses on the grid, so I'm gonna have, like, I don't have to estimate. Okay, so I've got on the y-axis, I've got 3.8 meters, and then that's at 3 seconds minus y1 is 2.6 at 2 seconds. So I have 1.2 meters over 1 second. How else could I write that? .2 meters per second. What is that? Of what? We just did something mathy, and, like, it corresponds to, like, real life? No way. You're kidding me, right? Like, okay, 1.2 meters a second. That's like a meter is about like that. Was the ball moving this far each second? Maybe this far because 1.2 ish. Crazy. Okay. So the takeaway on this one is this. So the slope for this guy, position versus time graph. So slope for a position versus time graph. The slope is rise over run. The rise is change in position over the change in x. On the x-axis, we're graphing time, clock readings. Change in clock reading or time duration. which is equal to, physics-wise, what name do we give this? Velocity, average velocity. Good with that? Okay. You might have realized that from the football workout lab. Okay. Good with that? See, in math class, they teach you all that stuff, but they don't really tell you why. This is like, why? It's those poor math teachers. they just get the short end of the stick on that. All right. So, give that one a shot. Talk to your neighbor. What do you guys say? Oh, that's better. Okay. Correct answer is. Oh, we got a smattering. Okay. So, what on a position versus time graph tells us speed or velocity? The slope. Do they have the same slopes? No. C's out. Okay. Displacement is change in position. Blue went from here to here. Purple went from here to here. The only thing that point of intersection tells you is they have the same position, same location at that moment in time. Good with that? So if you got it wrong, that's a great opportunity to write yourself a note. You learned something. Thumbs up when you have a guess. Have a conversation. Correct answer is A. Yay. Why? Has a greater slope. One more question. Tell your neighbor. We will discuss that tomorrow. Remember, your homework is to finish that worksheet that you had last night, 7 and 8.